Good morning, everyone, and thank you for joining today's session. My name is Alana Gluck, and I'm Engagement Lead for CReDO, the Climate Resilience Demonstrator. I'm delighted to be your host for today's showcase, in which we will share developments from the Ofwat Catalyst-funded project exploring extreme heat scenarios for the water sector. Next slide, please. Today's agenda is as follows. After this brief welcome and a bit of housekeeping information, I will hand it over to the project team to present the Breakthrough Innovation Fund CReDO Extreme Heat project. First, you will hear a brief project overview, followed by the background and context for CReDO. Next, you will learn about the use of climate data to develop asset models within the project. Then you will learn about the newly developed CReDO Asset Risk Tool and some of its uses. Finally, we'll provide an update on the CReDO digital twinning technology and a vision and next steps for its development. We will end with a facilitated question and answer session before closing the webinar. Next slide, please. Now for the housekeeping. We expect today's session to run at 1 hour and 30 minutes. We'll be using the Zoom Q&A feature, which you will be able to access through the toolbar at the bottom of your screen. You may submit questions to the host and panel at any time by clicking the Q&A feature. We will aim to answer as many questions as possible in the Q&A session before we close the webinar. If we're unable to answer your questions due to time constraints, we welcome you to contact us at the email you see on your screen. And now I'm delighted to pass on to my colleague and project sponsor from Anglian Water, Richard Buckingham, to introduce the project. Over to you, Richard.
Hello, thanks, Alana. So hello and welcome, everybody. My name is Richard Buckingham, and I'm the Climate Change and Carbon Manager at Anglian Water. So today we're presenting the outputs of a project funded by the Ofwat Catalyst programme, investigating the impact of extreme heat on asset failure. Next slide, please. So in the summer of 2022, temperatures in the Anglian Water region exceeded 40 degrees C in a single day. This was the first time that temperatures of over 40 degrees have been reached in the UK. During this event, we were required to employ emergency measures, such as using mobile air conditioning units to keep assets cool enough to operate. This temperature was so unusual, we had no experience of operating in such conditions. Air conditioning solutions such as these are energy, carbon, and cost intensive, and do not represent a suitably resilient long-term solution to ensuring asset operation in extreme heat. Whilst this was an extreme event, climate models are predicting increasing frequency, duration, and intensity of extreme heat events. In addition, there is a lack of understanding in the water industry about the risk of assets failing as a consequence of extreme heat events. And this is compounded by increased demand for water during these hot periods. And so the genesis of this project, we wanted to develop an understanding of if and how assets may fail as a consequence of extreme heat. Next slide, please. This project has been led by the Connected Places Catapult. I won't go through every one of the partners, but this is a talented team which has leveraged expertise through the use of a multidisciplinary team from business and academia. Next slide, please. So whilst the process of developing an understanding of if and how assets may fail as a consequence of extreme heat is complex, we wanted to be sure to deliver a solution that is simple to use, with outputs that are straightforward to interpret and be available to as many people as possible. The tool we've developed is free, web-based, and no downloads are required. To access the tool, the user is required to register, and that's it. We envisage the tool will be helpful to a range of stakeholders in the water sector: strategic planners, asset designers, operational teams, etc. For over 3 years, Anglian Water has been involved in the Climate Resilience Project, or CReDO. So CReDO is a digital twin created to understand how different infrastructure assets, water and water recycling assets through Anglian Water, power assets through UK Power Networks, and communications assets through BT, are interconnected with and interdependent upon one another. CReDO seeks to understand the stresses placed on assets as a consequence of climate events, and initially used a flooding scenario. The flooding scenario was used to test how assets within this interconnected and interdependent network can fail, and how this failure could cascade within the network. Small failures as a consequence of flooding can cascade through the network, leading to larger failures. By understanding how infrastructure networks are interconnected and interdependent, we can develop solutions to mitigate this wider infrastructure failure. So this Ofwat project focused on introducing a new climate stress factor, extreme heat, and the data architecture developed for the extreme heat asset risk tool aligns with that in CReDO and could allow water companies to share information with the CReDO platform in the future to grow the richness of the data set and therefore the insights available from CReDO. Colleagues later in this webinar will set out the process we employed to understand asset failure and the development of the CReDO asset risk tool, which we hope will be of great benefit to the sector. It's worth noting that the asset risk tool has identified cascade risk failure within individual assets, where failure in one area leads to failure in the asset, which will assist with identifying those specific elements in assets in which to concentrate resilience efforts. I hope you enjoy the following presentations, and I hope you find the outputs of this project valuable. Now I'll hand over to Sarah Hayes.
Thank you, Richard. Hello, I'm Sarah Hayes, and I'm a strategic advisor to CReDO. Next slide, please. CReDO starts with the problem that we don't understand the interdependencies across our infrastructure systems. So when we're hit by an extreme weather event, we don't know what will happen, which assets will fail, and at what point we might lose power, communications, and running water. The Climate Change Committee has been saying for some time now that we have a poor understanding of infrastructure interdependencies, and asset owners need to do something about it. The Joint Committee on National Security Strategy has also published a number of reports which show that we are not ready for the extreme storms that lie ahead, and this is going to cause major problems for us. Next slide. CReDO is all about improving resilience through data sharing and connecting up data across asset owners, which otherwise wouldn't be shared. We've been using CReDO to test out and demonstrate the power of bringing siloed data together. And as Baroness Brown, chair of the Adaptation Committee, says, asset owners really need to know who they are dependent on, and they need to share data to do that. Next slide. CReDO is a climate change adaptation digital twin. It brings together data across energy, water, and telecoms networks. And we've been working with Anglian Water, BT and Openreach, and UK Power Networks, who bring their people and their data to the project. In the CReDO digital twin, we're able to bring together data about assets so we can see the connections between the networks. And when you can see the connections, you can see the interdependencies across the system. In CReDO, we're interested to understand the impact of extreme weather events in the future across the infrastructure system. For example, what would happen if there's a flood or extreme heat? So we bring in climate and weather data to show what these extreme weather events would look like in the future. So imagine there was an extreme heat event. CReDO would show which assets might fail due to the heat, and then how that failure cascades across the system. So you would see the extent of power cuts, loss of communications, and water supply that might arise. So CReDO can help us think about how we might prepare for such events or respond in an emergency situation. So it helps us think about these big questions of system resilience and adaptation. Next slide, please. And so far, we've been focusing on the coordinated strategic resilience planning use case for CReDO, whereby CReDO can identify the most critical assets across the system that cause the cascade of failure. And if you can identify the most critical asset, so here in the diagram, it's the yellow dot, which represents an energy substation, and it has the red indicator with 3 pound signs next to it. And if that asset fails, then it causes failure across all the other connected assets in the system. So the blue dots, the water assets, would also fail. So it's possible to see that in order to increase the resilience of the water network assets, the blue dots, it's important to invest in and protect that energy asset, that yellow dot, which is at the root of the failure. And with the CReDO asset risk tool, we've been focusing on the blue dots in the diagram, understanding how and at what point would water assets fail under extreme heat conditions. So this asset risk tool is a key building block for CReDO. Next slide, please. And I just want to give you a sense of where we're at in the CReDO journey, because as I've mentioned, developing the asset risk tool is all part of the bigger CReDO journey. And this journey started in 2017 with the report Data for the Public Good, which recommended that there needs to be a pilot project to show the benefits of sharing data across sectors. And CReDO became this pilot project, launching in 2021 under the Centre for Digital Built Britain. After proving the concept in its first year, CReDO has been taken forward by Connected Places Catapult since April 2022 and has been developing a CReDO prototype to scale up. And we've been lucky enough to be able to gain innovation funding from both Ofwat and Ofgem to take CReDO forward. And we're in the process now of bidding for future funding in order to scale CReDO across both the energy and water sectors across the UK. So we're on a journey where we hope that ultimately infrastructure asset owners, regulators, and local authorities will be able to use CReDO as a tool to improve resilience across the whole of the infrastructure system. And the CReDO asset risk tool is a key building block of CReDO. In developing CReDO, in developing this tool, the asset risk tool, one of the problems we've had to address is the lack of historical asset failure data and climate data. So I'm going to hand over to Elliot, who is going to explain how we address that lack of data in this particular Catalyst project. Over to you, Elliot.
Thanks, Sarah, and hi everyone. I'm Elliot Christou, the CReDO technical lead at Connected Places Catapult. As you've heard, this project's main aim was to increase our understanding of the potential risks from heat events to water and wastewater industries. And we started this journey thinking about climate data. Next slide, please. So the first thing that we needed to do was define a heat event relevant to the water asset risk. So we worked with experts at Anglian Water, and we defined a heat event as the number of consecutive days where the maximum forecasted temperature is found to be within a specific range. Together with the experts, we identified 3 different temperature ranges: 30 to 35 degrees, 35 to 40, and 45 to 50, 40 to 45. And 4 different durations of events. So that's 1, 3, 7, and 14-day events. So if we consider all these combinations of those values, we have 12 different events in total. And we've considered those in the context, again, of 3 different warming scenarios: 1.5, 2, and 3 degrees warming. These parameters are all based on the tacit knowledge from asset managers and engineers at Anglian Water about the kinds of conditions that are likely to have an impact on their assets. We have a range from relatively mild conditions that might not cause too many problems, as well as more extreme and threatening heat waves in that data set. So now, considering this definition of a heat event, we have then taken the most recent iteration of UK climate projections data, also known as UKCP18, from the Met Office, and we've obtained a first estimation of how likely it is that different regions in England and Wales will experience these different kind of weather and heat events. Next slide, please. So it's important to mention that climate science is really, really complex as a field, and the models for which data exist in UKCP18 may not always precisely replicate the historical periods that we've seen. This is a concept called bias. And so that bias is the difference between what the climate models in UKCP18 predict and what we've actually seen in reality. So to make sure that our first estimation of the future provides a better representation of reality, We've used bias-corrected data kindly provided by Dr. Alan Kennedy-Atta and collaborators. And using this bias-corrected data is essentially a way of reducing the difference between what climate models say and what we will see in reality. So basically, a way of obtaining better, more representative results. Next slide, please. So to recap, we have these 12 combinations of temperatures and durations, and we're calling these heat events. As shown on the slide, some examples of these heat events include experiencing 30 to 35 degrees for a single day, or 35 to 40 degrees for 3 days, or 40 to 45 degrees for a week, etc., etc. So all the possible combinations of the values of temperature and duration together. Then for each of those events, we've worked with DMV and Professor Simon Tett to obtain the probability that we experience such conditions. For example, on the bottom of the slide, I'm showing there is a region in England that has a 47.2% chance of experiencing a temperature exactly between 30 to 35 degrees. And we have all chances of occurrence for all of these different events over England and Wales. Click, please. Now, this is a quick screenshot of what that data looks like, visualized in the CReDO asset risk tool for one of these events. And later in today's webinar, we'll be showing you how a user could access this data. But before we do, I'm going to spend a bit of time on asset modeling. Next slide, please. So by asset modeling, I mean, how can we use this climate data in conjunction with other information to obtain a first assessment of the risk to water and wastewater assets in these heat events? So this is all about how we understand how assets, so that might be a motor or it might be a whole site, are vulnerable to heat, and quantifying the associated risks. Next slide, please. In CReDO, we've been using a formal methodology called expert elicitation to build our asset models as Bayesian networks. We've been developing this approach over the past few years in collaboration with Professor Jim Smith, Dr. Kevin Wilson, and Professor Chris Dent. This approach can be really useful when you don't have much historic data to work with, either because of a lack of digitization or fault collection, or because the events haven't happened before, which is always the case for future extreme weather that is expected to happen from climate change. Many of these heat wave events we want to model haven't happened before in Great Britain, or have only taken place a limited number of times in recent years. So it's difficult to use more standard data-driven approaches like your machine learning to assess the corresponding risks. So in expert elicitation, you work with subject matter experts, who in this case are your engineers that do asset installations, maintenance, repairs, as well as operational managers and even suppliers of these assets. Basically, the experts are anyone that has deep knowledge and experience of how these assets in question behave in a wide variety of real-life situations, and can make reasonable inferences being guesses effectively, about what is likely or not likely to happen in the heat events. And so expert elicitation is a method that is used to collect, formalize, and encode the tacit knowledge, judgments, and opinions only found in the heads of the experts, and putting them into models so that we can assess the risk. Building models with expert elicitation is a two-stage process. We start with what we call structural elicitation. For this, we run a first round of interviews with the experts. The first objective of these is finding out about what types of assets and sites are vulnerable to heat, and then also structuring the chain of events that would cause the assets and sites to develop faults and impacts, which might be a supply interruption. Click, please. We call this collection of information a model structure. And here on the right, you have a very simple conceptual example of what a structure could look like. Essentially, it's a diagram of the chain of events from the start all the way to the impact. Finally, it's also valuable to find variables that can play a role in making the chain of events more or less likely. So if you think about an inverter trip, this could be the environment in which that inverter is installed, or whether there is forced ventilation cooling it down. Either of these could be key variables that make it trip or not in a 40-degree heat wave. These dependencies are really useful because then you can start to think about adaptation and mitigation to improve the resilience of the asset, as Sarah was talking about. Next slide, please. Once you have that information gathered in the model structure or in the chain of events, you can then move on to the second stage in the process that we called probability elicitation. This is now a second round of interviews where you would be asking the experts to make an inference, an informed guess about how likely they believe each event in the chain is to happen under different conditions of the temperature. At the end of the interview process, you effectively end up with probability data that, used together with that model structure, can be coded into a functioning mathematical model with the structure of a Bayesian network. So ultimately, you can think of this as a very advanced and targeted form of data collection on asset risk. Next slide, please. Of course, in water and wastewater networks, there are lots of different types of sites, assets, and equipment. So you might be wondering how we managed all of this complexity. We cannot do an elicitation for every single possibility. So what we've done is we've built the models for the main types of vulnerable equipment identified by the experts, and then we're using those as building blocks for more complex sites and other equipment. An example of a building block is a motor, and I'll walk through that now. So we start with the heat event as the input, and then click please. There are 3 events mechanisms of fault that could take place. There's the oil in the gearbox, which could thin to the point of causing damage or other problems. Or it could be that the motor overheats, where it reaches a safety limit and shuts down to avoid an unsafe situation. Or it could be that the inverter or starter trips. All these events could lead to a situation where the motor fails and stops working. And as I mentioned before, we also care about variables that could make those events more or less likely to happen. Click, please. So for the motor model, one variable is the environment in which the motor or its inverter are installed, which could be a steel container or a concrete building. Another variable is the demand on the motor and how hard it is having to work. And all of this together builds up our motor building block. Next slide, please. In addition to the motor block, we have listed 4 other key pieces of equipment or infrastructure. These are the process control electronics, standby generators, the impact on microbial population active in aeration or present in final settlement, and power supply infrastructure. This could be transformers or other equipment supplying electricity to the site. And we've used these building blocks models to represent a variety of equipment operating on different sites. So now let's take a look at how to use these building blocks to describe how a water pumping station behaves in a heat event. Next slide, please. So here we have a model structure for a pumping station. One of the key faults is that the water pump in the pumping station stops operating. As shown in the model, this can happen because of a problem with its motor. With our model, we could also consider the fact that the motor might be an environment that has forced ventilation. And if that ventilation fails, the pump will not immediately fail, but it will increase the likelihood of a fault because the pump will then be in a warmer environment. Click, please. Another way the pump can fail is if its control electronics develop a problem. And again, you could consider that these electronics are in a ventilated space, as represented by those grey boxes in the lower part of the structure. Click, please. And the third and final way in which the site is vulnerable is if it loses electricity supply, as represented by the structure on the right. So now we have this full and relatively complex structure, and we can now use our building blocks Click, please. So we take the motor model information and we insert it into the pumping station model. Then we do this for the process control electronics, the standby generator, and power supply infrastructure, as you can see with the animation. Reusing this information provides an efficient solution to modeling these complex sites without having to go and elicit similar information over and over again. Next slide, please. Now that we have functioning models for different machines and sites, we can use them to understand risk. So let's look at a simplified pumping station model where we've taken out the ventilation for simplicity. And with this model, we can answer different questions at different levels of granularity. Click, please. For example, we could ask the model, what is the chance that the pump motor fails? And it will give us an estimation. Or we could ask about the electronics of the pump. And again, we get an estimation. Click, please. We can also use the model to calculate joint events. For example, what is the chance the pump fails because of either a motor or an electronics failure? Click, please. We can also ask about the loss of power supply. Click, please. And we can estimate the chance of a supply interruption because of any of these issues together. Click, please. So to conclude, we use these models to build a granular understanding of the potential risks in heat events. More importantly, we can then use that information to help with decisions about where resilience investment in mitigation and adaptation will be most effective. So hopefully this has given you an understanding of how we've approached modeling asset risk and the types of outputs that we've obtained. The Connected Places and STFC data science teams have developed a modeling library in Python that can convert these model structures and expert opinion data into fully functioning models served as APIs. And now I'm going to be handing over to Holly, who's going to show you how a user could access these models.
Great, thank you so much, Elliot. Hi everyone, my name is Holly Hensler and I'm a Senior Product Manager here at Connected Places Catapult. Next slide, please. So how do you access the complex climate and asset modelling that Elliot has just shown? Introducing the CReDO risk tool, which, as Richard mentioned earlier, is a web-based product that enables users to understand the vulnerabilities of their assets in different climate events to help with planning, mitigations, and investment decision-making. The main ways the tool showcases this to the user are through a map, tabular numeric insights, and a collapsible tree format. Next slide, please. The tool will be useful for a mix of users, such as strategic planners, emergency planners, and users in asset engineering and infrastructure design. Today, though, we'll be focusing on our main use case for strategic planners. Next slide, please. So in a moment, we'll showcase our pre-recorded demo of the CReDO Asset Risk tool, showing how the tool works and some of its valuable use cases. Today, we'll be focusing on the strategic planner user type and how the tool will answer these questions here, which we'll explain in more detail. So without further ado, let's look at the CReDO Asset Risk tool in motion. Next slide, please. Hello, everyone, and welcome to the demonstration of the CReDO Asset Risk tool. There are multiple use cases the CReDO Asset Risk tool can solve for different user types. In this demo, we're going to be looking at the strategic planner user type with the following questions. What are the likelihoods of certain climate scenarios occurring across different parts of England and Wales up to 2079? In certain extreme heat climate scenarios, how likely are my selected sites going to fail? Within a site, how likely is each asset or component to fail up to the 50? In a collection of sites, which site is the most likely to fail in that selected climate scenario? Within a site, which component is likely to fail in that selected climate scenario? How do different climate scenarios impact the risk of a specific site or set of sites failing comparatively? And then combining both the probability of the climate scenario happening and that site failing in the chosen scenario, what is the overall likelihood of a selected site failing? In this demo, we'll take you through 4 stages of the tool. 1. Access to the tool and logging in. 2. Adding sites and data to the tool. 3. Running the model and viewing insights from the tool. And 4. Exporting data or insights outside of the tool. Starting with access to the tool, let's say the strategic planner finds out there is a new tool that will help them access the risk of their sites and assets due to extreme heat. The user can navigate to the CReDO Extreme project page on the Anglian Water Innovation Hub, or alternatively the CReDO Extreme summary page on the Digital Twin Hub. These pages provide background information about the tool and the security and data requirements for its use. Both of these pages navigate you to the detail page on the CReDO Asset Risk tool on the Digital Twin Hub, where you can click to register to the tool by clicking the Register for Access for the CReDO Asset Risk tool link and filling out the registration form. Once your registration has been accepted and an account has been created, you'll receive an email with your account details and a prompt to log into the tool and set up your multi-factor authentication. Please allow up to 2 working days for your account to be created. In your account registration email, click the Access to the CReDO Asset Risk tool link, which will direct you to the CReDO platform to access the Asset Risk tool. Remember, save this email as this is the link you will be using every time to log into the tool. Use your account details to log into the platform. As mentioned, the user will be prompted to complete their multi-factor authentication. This is an extra layer of security to access the tool deployed in a secure environment in Daphne, the data and analytics facility for national infrastructure. Use your usual authentication application to successfully input your code. With a successful login, the user will click the button that says Protected Area, and then for this use case, the strategic planner would click Asset Risk Tool out of the menu of CReDO-based applications. Don't worry if your menu doesn't look like this on the screen. Your menu is contingent on your role-based access, so it's likely you will only have access to the CReDO Asset Risk tool. After accessing the Asset Risk tool, the user is presented with an important disclaimer around the use of the tool, which includes the historical context of the tool, what it has been designed for, a disclaimer for using insights beyond explorative uses, and a link to download the user guide containing instructions on how to use the tool. We recommend reading the user guide before you use the tool and at the very least downloading this for later. The important disclaimer pop-out is also accessible from the bottom left of the tool under Help. If the user was to decline this pop-out, they will go back to the previous menu page, but when a user accepts the important disclaimer, they get full access to the tool like so. So, welcome to the tool. To start, let's begin by adding in asset sites. There are 2 ways to add in asset sites: default site and asset data that allows a bit of customization, or by bulk data upload. Let's take a look at the default data already set up for you in the tool. By clicking Add Default Data, the tool pulls through a set of 10 different sites ready for you to use. You can customize that default data, or alternatively just leave it as it is. For fun, let's customize the data. You can't customize the site type, but you can change the site name. So let's call this site Test Water Treatment Works 1. I'm going to place this site around North London by clicking the pin dropper, I also could have done that with the latitude and longitude coordinates. Below this, you can change the variables that define the site in more detail with drop-downs that are preset as so. But for now, I'm going to leave it as it is. I can do the same process for the other 9 default sites below if I wished, but for this demo, I'm going to leave it as it is. And there we go. You have your default data ready to go. Alternatively, if you wanted to run a larger set of sites, or you have your own data that you'd like to run in the tool, you can directly upload that data via a bulk upload. To do this, the user would download the bulk data Excel template on the left-hand side of the navigation of the tool. Opening up the template in Excel looks like this. Users are recommended to use the user guide found in the original important disclaimer that we've already downloaded, or if you need to re-download that file, you can click the Help button in the left-hand corner to see that pop up again. Following the instructions in the user guide and also the How to Use tab within the template, users can upload their data in the correct format for the tool. Once you've completed this and saved that file, you are now ready to upload that data. Back in the tool, under Excel Bulk Upload on the left-hand side, click Choose File and upload the new saved file you've made from the template. The upload can take up to 5 minutes, so please don't click any other part of the tool while you wait for your data to load. If there is a problem with your data file, you will see an error code, but otherwise, just be patient until you see your data load on the right-hand side of the tool, which confirms it's been uploaded successfully. A cheeky fast forward, and this is what you will see. Now, we have our data ready either from the default data choice that I showed previously or from the bulk upload, which I still have loaded here, so I'm going to use that. The user will then choose the climate scenario they want to test this against. The user chooses 3 options: how long the extreme heat event will last for, the temperature of extreme heat event over that time, and the general warming environment of the Earth. For this demonstration, let's choose a one-day 30 to 35 degrees event in a 1.5 degree warmed environment. As a reminder, if you get stuck or would like more information, please see the user guide. Click Run Models to submit. This can take around 15 seconds to run the models depending on how much data you have, so again, just be patient. So now here you can see this is the output page and these are the results for the chosen climate scenario. At the top, you can see what climate scenario the insights below are for, and then you can see the map view, which shows across England and Wales the likelihood of that chosen climate scenario happening up to 2079. Whilst this is on a scale, green tends to show that it's below 25% risk of occurring, orange shows between 25% and 50% of risk of occurring, and red shows it's over 50% risk. Now the map can be zoomed in and out of to get more detail over certain areas, so you might want to do this, for example, around where your site pins are. You can also click on the pins to get an overview of the impact as a quick snapshot. If you scroll down to the table below, you can see insights about your sites that you've uploaded. So here you can see the site impact showing you the failure chance of a site if that chosen climate scenario occurred, the likelihood of the climate scenario occurring in that location of the site under the heading of climate scenario, and then the overall combined likelihood of the site failing in that scenario and the chosen climate scenario happening at the location of the site under combined climate and impact. Hover over the eyes to get a better understanding for later. The table beneath digs into more detail about the components and assets within those sites, and this can be helpful for understanding why a site might be impacted and what components are most likely to fail within that site, thus where you need to focus your attention. You can download the insight data in both Excel and PDF formats by clicking either of these buttons on each of the tables. Excel downloads will open in Excel as so, and the PDF format opens like this, which may be more useful for a presentational style format. Both tables have search, filtering, and sort functionality, so if you want to drill down onto one site, you can type it into the search bar like so, and see only the insights for that site. Or say, for example, you wanted to see which of your sites had the highest chance of failure if that climate scenario was to happen, you can click here to sort this by the site impact column by highest failure chance. The search, filtering, and sort functionality can be very useful for the insights around things such as most likely to or least likely to with regards to failure, and then pinpointing the data that you might want to delve deeper into. The filtering and sorting can be then downloaded exactly as seen in the same way as before by clicking these buttons. The Excel and PDF documents will then just show the filtered or sorted data. If you further scroll down the page, you can get to the expandable and collapsible tree format, where you can see all the data at once and delve deeper into the components of the site and assets within those sites in a logical way. Let's take this site. We can expand the data into a substantial amount of detail to see what components of the asset and site are likely to fail in that chosen scenario. This is helpful for understanding how best to implement mitigation strategies, as you can see what is going to need protecting or replacing over other parts and where they sit in the site with their dependencies. It's important to note that the tree format is written in JSON and thus is preset for analytical work in that format. This means where it says %fail, it puts the percentage into decimal format. And bool fail means the boolean of that percentage, which is either 0 or 1 based on rounding of that percentage. Now you may say you wanted to compare against different climate scenarios for a specific site. Let me return to the input page by clicking the home button at the top of the page. This will open a new tab to make sure you don't lose your current scenario analysis, as the tool doesn't store any data for security. Once back at the input page, you can also duplicate this tab up the top here to see even more scenarios to compare. Taking the same steps as we did before, we can load in the bulk data or adapt to the default data and then choose a climate scenario on the left-hand navigation. I want to compare how difference in length of time of the climate event has an impact on the sites. So for this one, I'm going to run the same data file as we used before for the event of 1 day of a 30 to 35 degree climate event with a 1.5 degree warmer world. I click Run Models again, and once it's loaded, this is what we see. Then for the next tab, I choose a scenario of 3 days in a 30 to 35 degree climate event in a 3 degree warmer world. And this is what we see. By clicking between the tabs, I can compare the likelihood of that climate scenario occurring over England and Wales, in particular at my site locations, the likelihood of that site failing in that given climate scenario, and then the combined likelihood of it occurring overall. Looking at the site AASEA-B, we can see the insights for the 1 day at 30 to 35 degree weather event in a 1 degree warmer world scenario. Now we can compare these to the 3 day 30 to 35 degree scenario in the 3 degree warmer world and see how they differ. Seeing here that the likelihood of substantial site impact is higher, but the likelihood of that climate scenario occurring is actually much lower, and thus the actual combined likelihood of the site being substantially impacted by that 3-day scenario is lower than the 1 day scenario, telling us we need to care more about the mitigation strategies for the 1 day scenario. Here we can see for the 3-day scenario, the site at highest risk of substantial impact is AASEA-K. But for the 1 day scenario, the site at highest risk of impact is UUWWP. However, when we compare the combined risk, we actually find that UUWWP isn't as risky, and that actually AASEA-K is the site at highest risk of substantial impact across all the sites. Here, the strategic planner may want to look into detail of the AASEA-K site through the asset and component data in the asset table and the tree format below, and then utilise the sort and filter functions to delve further into detail to understand where best to propose mitigation strategies. These types of insights can be very helpful for users to see not only what sites, assets and components are at risk in certain scenarios, but also what to prioritise when planning mitigation strategies. Thank you for listening, and we hope you enjoy the tool.
Thank you, Holly. Hi, everyone. I'm Jethro Aykroyd from CMCL. My team and I have been responsible for the implementation of the digital twinning aspects of CReDO. And just as a reminder to the audience, you can submit questions at any time via the Q&A function on the bottom of the Zoom on your screen. Next slide, please. The CReDO Asset Risk Tool allows us to quantify the risk of failure of assets in given locations with respect to an extreme heat weather event. We can identify which assets are vulnerable and, if necessary, use information provided by the model to support decisions about how to increase the resilience of the individual assets. And this is where the asset risk tool leaves off. However, the assets don't exist in isolation. Click, please. They are parts of a wider network, which are themselves part of a connected infrastructure network. And this is important because a failure in one network can propagate through the other networks. These interdependencies and the increase in the level of cascading risk with climate change are exactly the concerns raised by the Climate Change Committee. Historically, these risks have not been addressed because the interdependencies between infrastructure sectors are not visible. And addressing this lack of visibility requires some form of data sharing. And in an ideal world, this would be implemented in a way that allows you to ensure that sensitive information remains protected while benefiting from insights calculated based on the overall connected network. And this is exactly what CReDO seeks to do. Next slide, please. Delivering the ability to share data securely to optimize decision-making across the connected infrastructure networks is where digital twinning enters the picture. CReDO uses a distributed architecture that allows asset owners to retain control of the data while securely sharing it with CReDO. Click, please. This data sharing is not the same as open data. We have developed a data sharing license that allows CReDO controlled access to data about the assets. And subject to this license, CReDO uses a secure compute environment to combine a temporary copy of the data describing the assets with data describing weather events and with contributed models to analyze the impact on the overall connected network. Click, please. CReDO is then able to return insights to the data providers about their assets. And subject to a suitable data sharing agreement that defines who can see what, it's also possible to provide additional types of insights and services. For example, decision support and automated reporting. The extreme heat weather data and the models that have been described today are examples of the components used by CReDO. They were developed as part of the CReDO digital twin and are shared by the CReDO asset risk tool. This means that any data that is prepared for use with the asset risk tool is integration ready for use with the digital twin. Click, please. To reiterate, the distributed architecture segregates the information provided by each data provider and allows control over who can receive insights. The insights are calculated on the basis of the overall connected network, and the data are only aggregated in the secure compute environment and only for the duration of the calculations needed to generate the insights. The combination of the data sharing license, the provision of a secure compute environment, and the design of the digital twin is such that users are able to share data and retrieve insights without compromising the security of their data assets. Next slide, please. One of the challenges for CReDO is to enable interoperability between all of the data and the tools, the models that it uses. And we achieve this using an internal data structure based on the use of ontologies to represent information as a knowledge graph. The ontologies are hierarchical. At the top of the hierarchy, we define concepts and relationships that apply throughout all of CReDO. We then define specializations of these concepts in lower level ontologies. We have introduced an intermediate level in the hierarchy where we define things that apply across sectors. So, for example, the concepts of water pumping station, water recycling center, and water treatment works, which are meaningful to multiple asset owners. The ontologies at the bottom of the hierarchy then define the specializations of these concepts and relationships that are specific to each asset owner. This approach is extensible because it is straightforward to add new ontologies, to define new specializations as needed to extend CReDO to describe new asset owners. The approach also confers interoperability in the sense that by writing the software used by CReDO in terms of the higher level ontologies, CReDO can use the same code to process data for each infrastructure network without the need to change the code when extending CReDO by adding new asset owners. This approach, the ontological approach, also maximizes outward compatibility because it permits the possibility of mapping from other data models to CReDO. And this includes mapping from whatever format is currently used by asset owners. And this is particularly important because, as I'm sure we all appreciate, digitalization is a journey, and we need to cater parties that are at different places on that journey. Next slide, please. So clearly, this diagram presents a simplified picture, and more detailed documentation is provided with the CReDO code. The following images are intended just to give you a flavor of what it looks like in practice. They show you the concepts and the relationships defined in the core ontology, plus the weather event ontology, plus the sector-specific ontologies, plus an Anglian water specific ontology. And the complexity in this, it isn't the size of the ontology, it's in making sure that the relationships are correct and support the practical implementation and use of CReDO. Next slide, please. So on the subject of the practical use of CReDO, I just wanted to give you a taste of what this might look like. In the demonstration of the asset risk tool, we focused on an extreme heat scenario. So here, I'm going to focus on a flood scenario. Next slide, please. This example uses synthetic asset data and grants us permission to see data from multiple asset networks. It calculates the response of the assets in the combined network to a flood hazard, where the red, orange, and grey borders around the assets on the visualization indicate different types of resilience problem. Click, please. It allows users to see details of the assets with the same access to granular information and the same ability to summarize and sift information across scenarios that you saw in the demonstration of the asset risk tool. And after this brief introduction, I'm going to hand back to Holly, who will tell you about the vision for the future of CReDO. Thank you.
Thank you, Jethro. Next slide, please. So CReDO's larger vision is to enable decision support for long-term strategic planning for resilience investment. In order for us to get to the decision support part of this, you can see here there are requirements of modelling the climate scenarios and the weather events, modelling how assets are impacted by those certain climate scenarios and the weather events happening, and then modelling the dependencies and the cascade failures through the wider system, both within that same sector and across infrastructure sectors, in order to have a true understanding of that resilience risk. Once you have that whole system understanding of the resilience risk, this is when we can start to include some of that economic modelling, cost-benefit analysis, and AI technologies to further deliver insights and recommendations for how best to make mitigation and investment decisions. Next click, please. So as mentioned earlier, the CReDO Asset Risk Tool has been focused on further developing the climate scenario modelling and asset risk modelling, which is vital for our larger vision to develop the decision support larger part of the platform. Next slide, please. Now, this is quite the diagram, I know, but this showcases in a more diagrammatic format the development and components required to develop CReDO to a mature, sustainable product. Next click, please. You can see here that this is where the CReDO Asset Risk Tool fits in this section around the site and asset risk modelling, with important arrows of the weather and data models and the digital twin knowledge graph feeding into that development, which is what Jethro has just been speaking about. Next slide, please. So as part of CReDO's long-term strategy, we're moving from this demonstrator into developing a full sustainable product. So moving from the climate resilience demonstrator to the climate resilience decision optimizer, all while still keeping that acronym. Here you can see our mission is really around enabling that coordinated decision-making and efficient investment by understanding those interdependencies and cascading risk. And our USP is really around enabling that whole system approach by connecting data across siloed organizations and sectors. Next slide, please. We are currently bucketing our users into 3 main user types that you can see here, and we are at different stages of development for their use cases, going from left to right in terms of development maturity. The users of the CReDO Asset Risk Tool tend to sit in that first bucket, just so you know where we are with that development. We have currently focused on the long-term strategic resilience planning and then risk reporting in our most recent product roadmap, but then we look forward to expanding to use cases in the emergency response sector in the future. Next slide, please. So today we've heard about some of the sectors and climate events we've been working on in recent development, but we can also expand far beyond our current remit. Expansions to CReDO can be amongst any of these categories you see here on the screen, such as the obvious ones of those climate events and sectors, but there are also expansions to other categories such as expanding that geography, non-climate scenarios, and technologies behind the data sharing. We're really looking forward to seeing where CReDO's development goes in the next couple of years, and we're really looking forward to taking you on that journey with us. And with that, I'll pass it over to Alana. Thank you.
Thank you so much, Holly, and thank you to our presenters for their excellent overview. I'd like to invite our panelists to join me back on the screen. And I'd also like to welcome my colleague from Anglian Water, Tom Burgoyne, who's joining our panel. He's an asset system specialist at Anglian Water, and he acted as Anglian Water's technical lead on this project. So welcome, Tom. We have a number of questions. We're going to try to get through as many as possible. The first question from our audience, I'm going to ask Tom if he wouldn't mind answering first. So our question is, can CReDO be used to reduce river, waterways, and sea pollution?
Yes, so indirectly, yes. This tool will be giving us insights into how assets might fail in these extreme heat situations. And obviously, by giving water companies more clarity around what might go wrong, they can maybe take mitigation efforts to correct those issues, and thereby prevent the pollutions that could come from them. So indirectly, I would say yes, but there's a number of steps between.
Wonderful. Thank you so much. Yeah. Thank you, Elliot.
Yeah, I could come in there and say that, yeah, like it's also about that cross-sector point of view as well with CReDO, right? So there's that longer term potential that you're reducing cascade failures. So whether that's from the telecoms network and how pollution incidents could come from that loss of communications or from that loss of power. Thanks.
Thank you, Elliot. Our next question that comes from the audience is, can CReDO be used to focus resources on infrastructure leak mitigation? And I think, Richard, you would be best placed to answer.
Yeah, thanks, Alana. I think it's similar to the answer that Tom mentioned before. It could be. I think just we've undertaken a related piece of work around we've called climate vulnerable mains. And as we move into the future and the climate changes, we're likely to see more frequency of drought. Now, under drought conditions, particularly this prolonged drought, the ground can shrink and move, and then pipes can burst as a consequence. Rather like what we have seen in the past around freeze thaw, we're likely to see ground moving due to heat and drought. So this heat tool talks about extreme heat, but heat and drought are not necessarily the same thing. So CReDO could be employed to think along the same kind of lines as the prolonged drought, and therefore the impact on soils, because the impact is different depending upon soil type, on pipe type, pipe age, etc., etc. But again, it's a complicated systems type issue that could in due course be addressed by CReDO and then contribute to the leak detection and so on.
Yeah,
Thank
and
you.
then I'll add in there, like in addition to that, this is kind of where the expert elicitation methodology can kind of come in really powerfully, right? Drought and what's happening underground can be very complex to model. So there's the potential that a good first step is to again take the opinions of experts, combine that with any other information that's available, and that could be another way of approaching this problem.
Could I just
Wonderful.
add on to that as well, just a little one? So we mentioned briefly that the Ofgem innovation funding has been moving some CReDO projects forwards. One of the areas they focused on is around extreme heats for their linear assets. So, for instance, the pylons, etc. So while we haven't focused on the linear assets in the water industry yet, certainly the CReDO digital twin in the broader sense is, certainly capable of beginning to assess that. So yes, I think it's a signpost for future work.
Thank you all. I just want to jump on that question around expert elicitation and use of data. So we have a question from Melissa Talick from the STREAM program. And the question is if CReDO is still using synthetic data, or if we've managed to get to a stage where we're using real data. And if so, are there any stories of real life insights that we can share?
Cool. I can start on this one. Thanks for the question. So with CReDO, we've actually been really fortunate to have real data from the start. So we've managed to get a data exploration license between UK Power Networks, Anglian Water, and BT Group to agree to share and store and connect their real data on Daphne's secure infrastructure. With that, so the reason why you will have seen synthetic data is that obviously that real data is a security risk and a commercial risk as well. And so whenever we're doing public demonstrations, that we use synthetic data to maintain the integrity. Around the use of that real data and how we've been using it. So both Sarah and Holly talked about like strategic resilience planning, and that's the use case that CReDO is really focused on. So within that, we've been using the sorts of asset risk models that you've seen today with those different mitigation strategies. So for example, for flooding, that could be a flood defense barrier locally placed at a site, or for heat, it could be forced ventilation. And we've integrated economic models associated with all of these different types of failures, as well as different types of investments in mitigation. And then we can perform cost benefit analysis to see what the overall cost would be of individual events, like an individual heat wave or an individual flood, but also a kind of spectrum of future events, so that you can have that kind of connected, targeted investment. And won't talk through all the numbers of that sort of stuff, but the return on investments of that have very large factors, as you might expect with future climate change and the potential for severe weather events.
Wonderful, thank you, Elliot. I have a question now for Holly about the asset risk tool. So if you're an asset owner, where will your data sit if you're using the tool?
Thanks, Anna. So this really picks off from what's just been spoken about, actually. So the CReDO asset risk tool is slightly different to CReDO, and so I'll defer to Jethro to speak about the actual digital twin. But what's great about the CReDO asset risk tool is not only is this actually designed to be as secure and is deployed in the equivalent environment to CReDO. So as mentioned in the demo, it's deployed on Daphne, so the data and analytics facility for national infrastructure, but also the fact that the tool takes the data that you're inputting as a user just to run the models. But it's really important to understand that the data is not permanently hosted in any external system. We actually, when we were developing it, we chose to make the user experience worse to make the security even better. So things like you saw, you have to duplicate your tabs, because as soon as you leave a tab, nothing's stored in the tool itself. So with regards to the asset risk tool, it's very much not stored at all. Obviously, the important thing is, you're using your own organization's data, recommended use your own computer managed by your organization, on a secure private internet connection, all of that. But yeah, if you want to learn more, we have quite a detailed response with regards to all of this on the user guide or the important disclaimer, and in particular the terms and conditions. So if it was the case that you wanted to look at that with more legal eyes, feel free.
Thank you, Holly. And can we go over to Jethro for the same question from a digital twin perspective?
Thank you. Well, I guess the digital twin is designed to facilitate data sharing to address the cascading risk across infrastructure networks. And it's designed, as a necessary component of this, it's designed not to have to load the data each time. As I said in the presentation, we use a distributed architecture, which is specifically intended to allow the possibility for asset owners to host their own data. So you could think of this as running some software provided by CReDO on your own computer system. This would allow CReDO controlled access to your data. So for example, it would allow the secure compute environment hosted within Daphne. So within the secure ring fence provided by the Science and Technologies Facility Council, it would allow it to access that data for the purpose of evaluating that cascading risk and sending insights back to you. And again, that process of accessing and processing the data is transient, with the insights being stored back with the original data, back under the control of the data owner. I hope that addresses the question. Thank you.
Thank you, Jethro. Now I'd like to go over to Sarah. We have an interesting question around how CReDO might be used to govern key performance indicators.
Yes, thank you, Alana. It certainly is an interesting question. So if we think of key performance indicators as resilience metrics, then a tool like CReDO helps you to think about those resilience metrics. And of course, across the different sectors, we don't have a full set of resilience metrics in place to help us fully understand what resilience means, because of course we can think about single sector resilience, so resilience in the water sector, or we can think about resilience across the whole infrastructure system. So we've been certainly keen to have a conversation with authorities, with regulators around what resilience metrics might be needed in the future and how we might go about developing those metrics. So I suppose that's perhaps from the water company point of view, is it might help a water company think about what are the resilience metrics and how are they measured. From a regulator point of view, and that sort of gets us into the question of governing KPIs, then it is that question, how would a regulator be able to monitor what's going on across water companies and potentially across a particular area, across the infrastructure system, so at a local area or at a national level. So this is something that we're certainly keen to explore, is how might a regulator or a local authority use CReDO in the future to be able to understand what's going on. And I think, if you're looking at it from different perspectives, the water company and the regulator, I think it's quite helpful to see CReDO as a collaborative tool to really have a better picture of what's going on across different sectors and what those levels of resilience are. So it's definitely something that we're keen to explore. And I think, we need more people to get involved. This is all about having conversations with different organisations to understand, what are the kind of resilience metrics you want to see, how might we develop CReDO in the future. Thank you.
Can I also add on to that as well? I think
Absolutely.
It's important as well. Sarah's exactly right that this is also not a new thought for us as well. This is something that we've been very, as you saw, that regulators and government being a potential user, and those resilience metrics is definitely something that we know CReDO is very, very useful for. So just the exciting thing is that this is already within our kind of product development pipeline. So it's not a brand new idea. So very much exactly as Sarah said, get involved and we can really work that out with you right from the get-go.
Thanks, Holly, and thank you, Sarah. We have another question, which I'm going to direct to Tom. So Tom, how impactful do you expect the extreme heat scenarios to be in biological efficiency of wastewater treatment? And is this something that will be possible to model in the same way as the impact of a motor failure, for example?
Yeah, so this is maybe a bit outside my comfort zone, but we were fortunate to have process scientists contributing to the project on the way through, so deferring to some of their insights. I'll answer the second question first. So the answer is yes, certainly it's been proven that this very flexible way of describing the assets can accommodate all sorts of different scenarios. We're just looking for those kind of failure modes and the stresses in exactly the same way. So that is how we've modelled the biological failure. In terms of understanding how impactful it is, I can't really give percentages from the probabilities, can't remember them, but it was actually something that I hadn't fully anticipated when we were going into this project, but we were told from anecdotal evidence from the 2022 heat wave that some of our aeration plants did start struggling. I think it was microbial populations overspeeding and nitrogen bubbles forming in final settlement tanks, which required us to take kind of measures to combat those impacts of the extreme heat. So I can't tell you how impactful, but certainly there are impacts to be managed, but this modelling technique can help us identify those.
Thank you, Tom. Our next question, I'm going to invite Elliot to answer, followed by Jethro. So how scalable is CReDO and who processes all this data?
Yeah, very good question. So we've been thinking about scalability from the start. So this all kind of came out of the idea of connected digital twins. We took a bit of a risk-based approach where we wanted to be pragmatic. So the early iterations of CReDO are stored in a centralized way so that all data is processed in one place. But we have plans to scale that out. So moving more towards a distributed way of hosting and processing data and models over time, which is the kind of key scalability component from a data sharing perspective. From a asset risk modeling perspective, of course, we've taken this approach with expert elicitation to fill in gaps in data and understanding. That in itself, we've come up with ways of making that more scalable. So we've thought about using these building blocks, as I showed it in the slides, as ways of reusing components once they've been elicited, but also through our sister complementary project with Ofgem. We are planning to build and we prototype building a digital elicitation tool that will also make that workshopping process more efficient and scalable. For the asset risk tool itself, because that is something that's a lot of the processing is done locally, that's obviously scalable inherently because it's based on the user system. There are some other nice scalability features of data and digital twinning that I'm going to hand over to Jethro to talk about.
Thanks, Elliot. I mean, I think I'd just like to emphasize the role of the distributed architecture in achieving scalability. As Elliot described initially, in the first phase of CReDO, we put all of the data together onto the same machine effectively in a single database. And clearly, this doesn't scale. It doesn't scale because of the constraints of the size of the machine you would need to host all of the data that you might want to host. It also doesn't scale because it implies that you would have to give data for someone or something to host, which is also not palatable. In contrast, the distributed architecture allows as many parties as wish to participate in CReDO because they can host their own data and, subject to that data sharing license, allow CReDO to process the data. The data processing itself, I've described it as happening within a secure compute environment, but this goes hand in hand with the possibility that that secure compute environment exists within a high performance computing or a parallel computing data center. And in that sense, when you want to allow the models to process the data, you can take advantage of having access to a large computing resource still within a secure, trusted research environment, but without the ability for it necessary to be the same physical machine doing all of the heavy lifting. And this is something that we've been considering from the outset of CReDO, and we believe that it is the key to enabling this design to scale. Thank you.
Thank you both. Next question I have for Richard. Is it true to say that the outputs are relative to the extent of systems included? I believe this is talking about the asset risk tool. For example, power generation impacts are not included.
Are we talking about, sorry, I'm just trying to get, if we're talking about CReDO, then the CReDO output does depend on the various infrastructure providers and infrastructure networks that are in the system. The larger the number of infrastructure elements, then the greater the understanding of their interactions and the greater power of the CReDO tool to deliver the kinds of resilience outcomes and conclusions that we would like it to. So they are relative to the extent of the systems involved, but this is the key. The more organizations that are involved, then the better the outcomes that CReDO can deliver, and we get a much more holistic view and understanding of how the whole system operates and interacts, and therefore we can better design resilience within those systems.
I can come in on the asset risk tool itself as well, if that helps. Yes, we have got standby generation. It was highlighted that overheating generators, if we lost power supply, they might be then struggling to act as that on-site power generation to support the assets in the face of that scenario. So yeah, that's absolutely been brought in, and that whole kind of supply chain, again, the sister project that Elliot mentions with UK Power Networks, they were undertaking various solicitations, and so we leveraged their understanding of transformers to understand that kind of power train as it comes through to the Anglian water sites, to the water industry sites, I should say. So in the asset risk tool, power generation has been included. In the wider CReDO project at the moment, I believe it's just distribution network operators. We don't have the power stations in yet, but as Richard has said, absolutely, the more that come to the party, the richer the model.
Wonderful. Thank you, Tom and Richard. I have one last question, and I'm going to open this up to the panel. So if you could put your hands up, and I'll call on you to avoid some chaos in answering. So our last question is around critical national infrastructure. So how does CReDO handle the sensitivities related to critical national infrastructure information? Hands, please. Who would like to go first? Richard.
Yeah, I think it comes down to the data security protocols that are in place. I mean, Holly's talked about that, and all the information is available, and the data sharing licenses. So we understand that we are dealing with assets that are important for the nation, and therefore we need to be very careful about how the information is stored and accessed and shared and so on. So we have the data sharing agreements and so on. And Jethro has talked as well about how the information essentially goes from in our case, a water company into the CReDO system, is then used and then gets taken back out into the water company. So there are protections there. The other thing I would say, and then you saw in some of Jethro's slides and indeed Sarah's slides, where there was schematics of where the assets are and the little arrows and how they all connect. Now, much of those slides, if you like, are produced using synthetic data, but we've obviously done the work using the real data. It's just we just don't present the real data for some of the very issues that we talk about CNI. So I would say this revolves around data security, which we've gone to great lengths to ensure should not cause a problem.
Thank you, Richard. Elliot, please come in.
Yeah, no, really nice answer from Richard. I just wanted to add that it's obviously about being very focused on the use cases and having data that are only for the use cases that you need, so that everything's kind of taking a risk-based approach and is controlled in what data is being shared. More on that is that we've been starting to work and think about the concept of like need to know data. So what is that minimal information that needs to be shared between critical infrastructure providers for that use case? And so you're never exposing the whole network, the whole infrastructure, the whole system at any one time. Thanks.
Thank you. Anyone else would like to comment on CReDO and critical national infrastructure?
I'd quite like to just second Elliot's point and to give an example, if I may. The point Elliot made was to think about the use case and letting that drive what data is shared. One of the things that you need to know in the CReDO use case is you need to know what weather is experienced at the location of an asset. But you don't have to share the location of the asset to do that. You could send the weather data to wherever that the information about the asset is held, and you don't need to send the location of the asset outwards. You could send the location of the weather data inwards, and in doing that, you could design the modeling in a way that avoids the need to share data that you would rather keep secure. So you could design out the need to share that sensitive information. I hope that's helpful. Thank you.
Thank you so much, Jethro, and thank you to all of our panelists for joining us and for your really thoughtful answers. And thank you to the audience again for your questions. If we haven't answered your question, we'll endeavor to do so offline via email. So please do stay in touch. With that, I will close our Q&A. Thank you. Speakers, except for Richard, you can shut your cameras. And Richard, I'll invite you to give your final thoughts.
Thank you, Alana. So first of all, a big thank you to all the presenters today and the wider project team for making the project and this event happen. And secondly, thanks to all of you who've attended and asked questions and made it such an enjoyable one. I would like to end by asking you to use the tool and better understand the risks posed to your assets as a consequence of extreme heat. As you've seen, the tool is free, easy to use, and the results are easily interpreted. And if I don't want to completely labour the point, but this tool is secure too. But if you come across any issues with the tool, please contact us using the email addresses that are shortly going to be described by Alana. So with regard to the wider CReDO, I would urge you to get involved. The power of the concept is greatly enhanced as more asset owners and operators allow their data to be used, and we can build a more holistic view of infrastructure resilience. We know that climate change is with us and that we can't be sure of the future, and this uncertainty presents risks to the reliability of our infrastructure. CReDO presents us with an opportunity to better plan for this uncertainty and to deliver improved resilience. And with many actors working in the same direction, we can better secure a functioning, resilient infrastructure network into the future. So Alana, back to you.
Thank you, Richard. And just before we close, thank you all once again for attending. To register for access to the CReDO Asset Risk Tool, you'll see that you'll have access either the DT Hub website, Digital Twin Hub, which you'll see on your screen. There's also a QR code, as well as on the Anglian Water Innovation Hub website. I also want to give a sincere thank you to our colleagues, both at the DT Hub and with Anglian Water's Innovation Hub for support for this webinar, and also in helping us to promote the findings and outputs of this project. And last but not least, as my colleagues have said, please do get in touch for more information about CReDO and to get involved. You'll see the email at the bottom of your screen, which is credo@cp.catapult.org.uk. Thank you once again, and we look forward to speaking with you soon. Have a wonderful day.